Hi guys, in this video we'll try to understand everything about AWS CI/CD pipeline. Now in this video we will try to create a CI/CD pipeline for a front-end application using React. Now we will see how we use different phases, how we use different cycles to basically create an automated deployment and integration using only AWS services. So we're not going to use any other services, we'll be using completely the AWS services. So we'll basically look on how different services we use of AWS and combine them together to create a CI/CD workflow. Let's get to the video. So the first thing we need to understand is what kind of architecture or the services we will be using. So let's get to that. So first thing, you need a place to store your code base. Now, so in a real life example, you were working in a team, so you need a place to basically store your repository, your code files, and from where other team members can work on it. So if you've worked with repository hosting services like GitHub, GitLab, or Bitbucket, AWS have its own code repository service, which is CodeCommit. So we'll be using CodeCommit in this one. So we'll have that. So the React application we'll be working on will be stored up here. Okay, so like other team members can work on it. So the first service we'll be using is going to be CodeCommit to store the repositories. Okay, so the next thing will be CodeBuild. Now CodeBuild is a service by AWS to basically create build projects. Now build projects are nothing but the compiled version of your code. Now if in terms of React, if we talk about, we need HTML files and we need some JavaScript to basically render the React application over to the browser, because browser understand only HTML and JavaScript. So to build all those things, so the CodeCommit have all the repository, right? So all the codes we write can be bundled into a single file, and that is done by CodeBuild. Now CodeBuild basically uses different kind of platforms to do that, but we'll be using Docker to basically combine our code base and basically generate a Docker image out of it. So we'll see how Docker image works with CodeBuild. Okay, so if you narrow down this step, we'll have another step here, which is going to be CodeBuild will basically create Docker image. Okay, now Docker image, we need to push it somewhere to store it. If you've worked with other Docker image container registry, you must have heard about Docker Hub. So what we do there, we basically push our images, or if you need any other image, suppose like Node, Nginx, we basically pull that down. So it is basically a marketplace kind of thing. So we'll be using that, but we'll be using this service which AWS provide. Now the AWS provide us with container registry, which is known as Elastic Container Registry, which works very similarly to what Docker Hub works like. Okay, so we'll basically push that image which is generated by CodeBuild and we'll push it to Docker Hub so we can use it for our CI/CD pipeline. Okay, now the next thing, so the fifth step, will have a code deploy. Now code deploy is basically a way to deploy our application to servers. So code deploy will basically deploy our application to the servers. Okay, now what services we will be using for this one is ECR, so which stand for Elastic Container Service. Now Elastic Container Service is basically used to deploy your application to different servers. Now we're not going to use EC2 in this one, we'll basically use Fargate. We'll understand more about Fargate in the video only. So we're using Fargate, which basically does all the things on its own. You don't need to provision any servers, it can scale automatically and all those stuff. We'll see how it really works. Okay, now the code deploy will basically go to ECS, that is Elastic Container Service, to basically launch our application over AWS Fargate. Then Fargate will basically be sitting behind a application load balancer. Yeah, so we'll be using a load balancer to basically host our endpoint. Okay, so for like auto scaling and all those stuff, so we'll be looking on target groups, load balancers, and all the stuff. Okay, so ALB will be like Fargate will connect to ELB to basically transfer traffic. So to traffic will be hit on ALB, and then Fargate will handle that, okay, to different servers which it deploys. And then we'll have, at the last moment, we'll have our internet. So this is the end user. Okay, now the overall CI/CD pipeline, we have one more service which is the combination of all this. So we have CI/CD pipeline, CodePipeline. So CodePipeline comprises of all the services which we talked about, and it basically combines it and do it automatically. Now what happens is, like, if you go to the first step, the user pushes some code, everything will be happen automatically. Okay, now we'll have a look at one more feature. We'll have a look at one more feature with CodePipeline to manual or auto deploy directly to the servers. Okay, so we'll see how it really works. So we'll basically go upon and look on the different services we will be working with AWS tool. So in overall we'll be using around 8 or 9 AWS services. So this video is going to be a pretty large one, but for your convenience I will be adding different chapters, so you can like go to the different chapters and see the one you really require. So this is a full depth and hands-on video. I hope you will like it. So let's get into the video part. The AWS console, we need to find CodeCommit service. So CodeCommit service is similar to like GitHub, GitLab or Bitbucket. So it helps us to host our code repository on this platform. Let us first go to CodeCommit. So you can search for CodeCommit. Okay, now this is the overall interface we will be working on. So it contains all the part related to CI/CD, not only the code commit part, it all have all the services related to CI/CD. So it have artifacts, build part, deploy part, and the pipeline part. So first of all, we will take a look on the code commit part, where we will basically be hosting our repository. So in the code commit part, you can click on repository. Okay, so in the repository part, let's go and create a repository. So I'm going to click create repository, and I'm going to write the name of the repository. So I'm going to write it a simple name, CI React. Okay, apart from that, you don't need to do anything. Just go and click create. And this is just some steps you need to follow in order to SSH or to clone this repository or to work with this repository from your local system to CodeCommit. So what I'm going to do is to just copy this HTTPS link, okay, which will help us to clone this repository on our local system. So let's go to it. So let's paste it here. So this command and press enter. Now this will basically copy all the repository files from AWS CodeCommit to our local system. So currently we don't have any files, so this is what is the warning showing up. You can find some codes already we have, so let me open that part first. So let me open that in VS Code. So as you can see, we have some files here which I have already generated. I have already created this file. So this is basically a simple React application which basically serves over the Nginx server. Okay, so I have created a Docker file, so we don't need to have to worry about that. So what we're going to do is simply copy all this stuff back to our empty repository, and then we can push those to CodeCommit to start working with our CI/CD pipeline. So let me just open this, and I'm going to copy this, and I'm going to paste it up here. Okay, now what I'm going to do is I'm going to close this codes part, and I'll just open the CI React part in VS Code now. Okay, so now our files are here, and now you can see I have the VS Code is showing me the files are highlighted with green color, meaning that these files are not yet been pushed to the repository. So let us push all this stuff and see how this really works. So I'll open the integrated terminal in the in the VS Code only. As you can see, I'm in the master branch, so I'm gonna do git status first. So it will show me the files which we need to be pushed to the repository, the remote repository, that is the CodeCommit. So I'm gonna add it here. So first I will be add the files. So git add. So this is all the normal git steps we follow. So we have added that, and what we're gonna do is to just commit this changes to CodeCommit. Okay, now let us push this changes. As soon as you push it and you go to CodeCommit and you refresh it here, you can see all your files are here now. So our project is ready to be like deployed over the internet and to integrate with all others services like the pipeline and build one. So let's get to the other part now. Okay, So our repository is ready. Now the next thing we need is some place to store our Docker image. Just like the repository hosting our code, we need something to host our Docker image. So if you've worked with Docker, you have probably heard of a Docker Hub. So it is similar to what we are using as like GitHub, CodeCommit. So it basically hosts your Docker images. As we are using all the services related to AWS, so we won't be using Docker Hub. So we will be using Elastic Container Registry, ECR, which is the alternative of Docker Hub in AWS. Let's search here Elastic Container Registry. Okay, so here in Elastic Container Registry, it gives us two options, that is the private and public repository. So if you're working with an production and a professional project, you must use private repository. Okay, so we'll be using that only. So let's create a private repository. Okay, now as I told you, the visibility part, that is the private and public, we'll be going with private. And the name, so name will be place where all our images will be stored. So let me name it as CI React application, and it is going to be prefixed with our account ID. Okay, apart from that, we don't need to do anything in this settings, so we are good to go. If you want to add some encryption, you can add it using the KMS encryption. You can just enable it and you can add it to your Docker image. Okay, create the repository. Okay, now this repository is created and we will be using it. So this is the repository name, CI React application, and if we open this, you can see it will have multiple images. Be using this name to interact using our CodePipeline. Okay, let me duplicate this tab. Let's get back to our CodeCommit, and the next thing we will be doing is the next part, which is the code build part. So what is code build? Now code build is basically a way of building our project. So if you worked with any other programming language, you must know that we basically write code locally and then we build it and make a whole package of it. So if you're working with a Node project or a React application, what you do, you use the command npm run build or yarn build, and it basically generates a whole folder, whole directory containing of the HTML and bunch of JavaScript. So that is what the build does. It basically compiles all your code. Let's see how this really works. So let's go and click on get started. Okay, so we are in code build, so it basically builds our project using the image we provide or the application code we provide. So in our case, we will be providing the Docker image. Okay, so let's create the project name. It can be anything. I will name it as React Frontend. Okay, now the source, as I told you, it can be from anywhere. It can be from S3, GitHub, Bitbucket, or like any other platform, but as we are working with CodeCommit, we use this one. The repository is the same, CI React, and the branch will be master. Apart from that, in the source part, we are good to go. Now the next part is the environment part. So to understand environment, think of it like if you're running your Docker image locally on your system. Okay, so what you need an environment. Maybe it can be a Linux environment, it can be a Mac environment, or it can be a Windows environment. Same thing here, we will be selecting a Linux environment to basically run our Docker image and basically run Docker to create the build files. Okay, so I'll use Amazon Linux. In the runtime, use standard, and in the image part, to select the latest one, that is 5.0 for now. Okay, now this is required if you're working with a Docker file, Docker image, so you need to do this. So let us enable this. Okay, now code build will create a new service role for you, and this service role basically have all the functionality required. Basically use code build to access other AWS resources. Okay, so we will be changing multiple things here in this role, but for now it's fine. In the additional configuration, we don't need to change anything like timeout and all those stuff. VPC, it's fine. The one thing we need to change is the environment variables. Now if you're working with Docker file, I will show you the Docker file we will be working on. So we need to pass some environment variables which will be passed to Docker file, which will generate that image. Okay, so we'll add that environment variables here, and that can be read by Docker file from the environment that we used up here, that is the Amazon Linux tool. Okay, so let me add that. I've added all the environment variables name. Now let us feed the value to it. So the region will be simple AP South 1 in my case. Okay, so this is AP South 1. Account ID, you can get it from here. That is the numeric value. Image tag will be latest always, and the image repo name, you can simply get it from the repository which you just created. Cool. So our environment variables is ready. I will show you how we will be using this. So yeah, so this one is ready and we don't need to do anything here. Now the next part is the build spec file. So this build spec file is basically a file written in a YAML format. So basically it contains the steps that will be followed build your project. So we will look at one of the build spec file, and we will see how AWS code build will build your project reading the steps from your build spec file. Okay, this need to be in the root directory of our repository. Currently we don't have it. If we go to CodeCommit, we don't have that. Okay, so we will add it. So we will be using build spec file. We will be pushing a new build spec file to our repository. The next thing is artifact. So artifact is basically used to, like, after the build is completed, where you want to store that artifact, some like the build files. If you're working with a React application, it basically generates a dist folder and where we want to put that. So the best place is to put it to S3, and we will look how we'll do that. The next thing is CloudWatch logs. If you want to add it, you can add it, but we're not going to do that. So the project, I think, is ready. So let's create build project. So our build project is ready. Now as I told you, we were working with a service role that code build generate, but we need to add some more policies to it so it can access our container registry ECR and fetch the basically put the image and pull the image over there. Okay, so to do that, let's go to IAM. In IAM, let's go to roles, and here we will find code build service role. Let me see which one is it. Environment, this one. Okay, so let me copy this, open this one. Now as you can see, we have a code, as we have only one policy, so let's add some policies to it. So let me add attach policies, and the first one we'll add is an ECR policy. Okay, and one thing more we need to add is the CodeCommit full access. So I've given it full access, but if you're working as a production level, or you want to have some policies which are like you don't want to give every policies, you can just select one or two, but I'm selecting the full access here. So let's go to add permissions. So this permission is added. Our build project is basically ready. Now the way to test this is that we can start the build and it will basically generate the files and all those stuff. It will basically build our project. But now before we start the build, we need to add that build spec file which we were talking while setting up the configuration. So it is required. So let's go back to VS Code and add that build spec file and see how it really works. Okay, now in VS Code, as you can see, this is the build spec file. Okay, so this is a simple build spec file. You can get it over from the internet, and it really works very well. So let us tear down PyPub line by line how it really works. So okay, so build spec file is an YAML written file. Okay, so the indentation we follow here is really essential to follow. Okay, so the first part is the version, which is 0.2, which is basically the code build version or the YAML version we will be using here. The next thing is the phases. So we have multiple phases. The first phase is pre-build, then we have build, and then we have post build. The name of the phases is self-explanatory. So the first one is pre-build, build, and post build. Now the pre-build is basically the place where we basically gather everything. Like we basically log in to the ECR, we basically tag the image and all those stuff. We do it here. Okay, in the build part, we basically build the Docker image, okay, using the tagging and all those stuff. And in the post build part, we basically push the image back to the Docker registry. That is the ECR in our case. Okay, now as you can see, we are using the environment variables we passed while configuring the code build. So this is the environment variables. And the last part is the artifact part. So the artifact part is the part where the code build will generate some artifacts, and that will be stored to S3 in this file. Okay, cool. So this is done. So let's just add it to our repository so the code build can read it from there. Okay, So let me save this and add build spec. The naming should be the same as mentioned in the configuration. Okay, so I'll be using VS Code integrated git to push the changes back to CodeCommit. Added build spec commit, and let's just push the change. Okay, so let us verify. So we have the build spec here. Now we are ready to basically start to build. So let's start to build manually this time and see how it really generates the Docker image over to ECR. Okay, so now we are ready to basically start the build manually for now. So let's start the build manually. So as you can see, the build is started, and you can basically go and look at the logs, phase details. So currently it is provisioning the environment, that is the Amazon Linux 2. Then we have reports up here. Then we have the environment variables. Then we have the build details, all the build settings like the VPC, environment variables, service role, and all those stuff is here. Then we have resource utilization, where we can monitor the resources. So let's go back to build logs and wait a while. So as you can see, we are logging into the ECR. Okay, so if you look at the build spec file, so this one is echoing, so the logging into ECR. Okay, then login is succeeded, then it is running this command. Okay, all this command, and now we are basically using the docker build command. So let's wait for a while. Okay, now you can see that our build is succeeded. You can see it succeeded now. Now let's go back to ECR and see if the ECR have the latest image. Okay, so let's go back to ECR. So this is our ECR, and let's go back to the repository. So as you can see, we have our build here. So the build and the latest tag. So the image is here. So this image we can use in the code deploy part. So this is ready, and now we can go back to CodeCommit, and we can start with the deploy part. Okay, so our code build part is done. Now before we get to code deploy, we need to do some settings first. So let's first understand how this really works. So we have the source file, okay, and then we have the build file. So build will generate image, Docker image. Now we need some way to deploy that image over to the servers. Okay, so in the server part, we will be using ECS, which is Elastic Container Service. We will be using ECS in a Fargate mode. Okay, so we don't need to provision any EC2 and all those stuff. It will be done by ECS. So we'll be using ECS for that. Okay, and that ECS will be sitting behind a load balancer. So we need to configure a load balancer where the user will hit and your website or the React application will be rendered over the browser. So let's first configure the load balancer, and then we will start with the deploy part. Okay, so to go to that, to use load balancers, so you need to go to EC2. In EC2 you need to go to load balancers, and here we will be creating a new load balancer. So let's create load balancer, and we'll be using an application load balancer. Load balancer name, I'll name it as front end React. Okay, it is going to be internet facing. IP address will be IPv4. Okay, VPC will be the default. If you have another, or if you want to use something else, you can add it from here. Mappings will be on all the subnets, so let's select all of them. Okay, security group, it is on default, but we need to create a new security group because we will be working on the port 80, which we need to make it accessible from all over the internet. Okay, so I have already one, but let's create another one. Security group will be React front end SG. Description is fine, VPC is fine. In the add rule, in the inbound rules, we need to add the rule. Okay, so let me select HTTP here. Everything is fine, 80 port is fine, range is fine, and the CIDR block we need to select it from anywhere over the internet. Okay, So this is done. We need to remember this name, React Frontend SG. Let's create the security group. We need to add a description. Let's add that. Create. Okay, so it is created. We will be using this one, so let's copy this one, and if you go up here and you click on refresh, you can see it is available here. So we'll use this one. Okay, and we'll basically remove the default one. Okay, now the next thing is we need to add a target group. So the target group will be the EC2 instances will be forwarding our traffic to. So let us create a target group as well. So we need to add some settings here. So the first settings we need for the Fargate and all those stuff, we need to use IP address. We don't have instances in a Fargate. Okay, so IP address is fine. Target group name, React front end TG will be fine. Port is fine. This one is fine. VPC is fine. Health check we don't need. Apart from that, everything is fine. Okay, so let us go next. Let's choose the network. That's fine. Everything is fine here. Okay, so let us just create the target group. Okay, so the target group is also ready. Okay, now let's go back to load balancer, and here I will refresh and I'll select the target group. Okay, this part is done. We don't need to add any services. We don't need to add any tags. As you can see, the summary is fine. We are using the React Frontend SG which we created. Network mappings is also fine, and the listeners and routing we added the target group which we created. Okay, everything looks fine. Let's create the load balancer, and let's go to view load balancer. This will take time, so we can move to our code deploy part. Now our load balancer is ready. Target group is also ready. Now we are ready for the code deploy part. Now for the deployment part, we'll be using another AWS service, which is ECS, Elastic Container Service, with the Fargate mode. Now what is Elastic Container Service? It is a service which basically used to deploy application with Fargate or EC2. If we are using Fargate, we don't need to like provision servers, we don't need to initialize EC2 instances and all those stuff. It can be done, all those stuff is been done by ECS only, so we'll be using that. So let's get to Amazon ECS. Okay, and here we'll start by creating a new cluster, and then we'll add task definition to it. So let's create a cluster first. Will we use a networking only cluster, and for the name we'll be using React Frontend. We don't need a VPC. We'll be using the existing VPC. Let's create to view cluster. Okay, so as you can see, our React frontend is ready. Now let's go to task definition and create a new task definition. Okay, so as I told you, we'll be using Fargate, so we don't need to provision anything. AWS will manage everything, so we'll be using this one. Click on that, go to next step. Here we'll need to add the task definition name, so I'll write React front end TD. Okay, then this is Fargate. For the task execution role, select ECS. The network mode is fine. The operating system is Linux. Execution role is fine, and the task memory will be 1 GB and CPU will be 0.25 CPU. So this is enough for our use case for now. Okay, now let's add the container. So when you click on this, you need to add the container name and all those stuff. So to get the container name, just go to your CI ECR and just get the container name. So CI application will be fine. Put it here, and for the image part, we need to add it this one. Okay, now this is the manual step which we are doing, but after we have configured CodePipeline and code deploy it, we don't need to do all this stuff. It will be done automatically. Okay, everything is fine up here, and in the port part, just add 80. Let's click on add and create. Okay, so it has been created. Let's go and view task definition. So as you can see, if we go to task definition, it is created. You can see the execution role and the image which we'll be using. So the task definition is ready. So now let's use a service to launch this. So let's go to React Frontend in the cluster, and let's create a service. Use Fargate task definition is React front end. Service name, number of tasks, let's add it to. For the service name, we need to add a service name, so let us add React front end app. Apart from that, everything is fine. We need rolling update, that is fine. So let us create next step. Okay, in the VPC part, we will be using the default VPC with all the subnets. Security group is fine. This is also fine. Now in the load balancing, we need to select the load balancer which we created. So let's click on application load balancer and just select the load balancer from here. For me it's front end React. Okay, your container port is fine, 8080 is fine, everything's fine. Let's go and click on next step. Okay, so we need to add the load balancer. Okay, so we need to add that. So 8080 is fine. Okay, and for the target group, we need to select the target group which we created. Okay, now let's go on next step. We don't need to do anything here. Next, and then create service. Okay, so the service has been created. Let's go to view service and let's wait the status change to running. So let us wait. Okay, now the status is running. Now let's go back to our load balancer, which is here, and select this and get the DNS name. Copy it, put it in the browser, and voila, you can see your React application over on the ALB, and it is running in a full auto scaling mode. Okay, now the last bit is to configure the code deploy and the code pipeline. So to do that, let's create a pipeline. So go to pipelines. Okay, let's create a new pipeline. I'll name it front end React application app. Okay, service role, everything is fine. Let's go to let us see if we need to change anything from the advanced setting. We don't need to do that. Click on next. Source provider will be CodeCommit. Repository CI React, and the branch is master. Everything is fine. Click on next. Build, we have code build, and we need to select the project, which is React front end. Okay, we don't need to add the environment here, as we have added that in the project only. Click on next. Deploy, we need to select Amazon ECS. Okay, cluster name, we have React front end. Service name, we have React front end app. And image definition file, you need to add it here. So if you remember, you have added that in your artifact. So we just need to copy this and put it here. Okay, click on next. Everything looks fine. Let's go and create the pipeline. Okay, so pipeline has been created and it has already been started. So let us see the execution and all those stuff. So you can see we have multiple stages here. So the source, build, and deploy. So source will be the code commit part where it will get the source. As you can see, this is the latest commit, added build spec, and the build will be the building of the Docker image and all the stuff, pushing and pulling everything. Every step we put in the build spec file will be done here. And the last one is deploy, where the React application will be deployed on ECS. Okay, now this is deploying. Let us wait for a while, and then we will do the automatic part. Okay, now let us make some changes to our React application. So let's see how we can run this pipeline automatically whenever we push something on the master branch. So as you can see, I will make some changes to the React application and see if it reflects it here. Okay, so let's go back to VS Code and we'll change something in our React application. So let's go to what we can change. Yeah, we can change the background color. So let's select some reddish color so that it can be visible. Okay, save it, and as you can see, we have one file that is to be committed. Let's add it, commit it, and as soon as I push it, pipeline should start running. So let us wait. Okay, so as you can see, the code pipeline has started and our new commit, that is the changed color, has been picked by code pipeline, and now the build part is starting. So let us wait for the build and the deploy part. Okay, Now one thing you can do here, if so what I do in a production or real application, what I do is add another step here. So you can add a step here by going to edit, and you can add a stage here, like something like an approval or something like that. So let me add and show you how we can do that. So approval, add stage, and let us add the action name. So this is going to be a simple manual approval. So you can select manual approval. We don't need to add anything up here. Okay, just click on done and then save. So as soon as you do it, you can see we have a manual approval. So as soon as the build is done, it will go to the approval part. If the build succeed or if everything is fine, then only you will click on the approval, which will be a simple yes no button, and then it will deploy your application. So let's wait and see if it goes to the approval stage or not. Okay, so let's wait for the build to complete. So you can, if you want to see, you can see the details, the logs and everything of build. Okay, so this will open up the build project only. So yeah, so let's wait for a while. Okay, now you can see our pipeline has been stopped in the approval stage. Now we need to approve it, then only it will going to deploy our changes. So let's go and approve this. Approve, and as soon as you approve it, it will go to the ECS part. So let's wait for a while. Okay, so as you can see the deploy part is started now. So let's wait for the ECS to get deployed, and then we can see the changes. Okay, now as you can see the deploy part is also done. Now if you go back to our ELB URL and if we refresh, you can see the changes has been reflected correctly. So our load balancer, our ECS and our pipeline is working absolutely correctly. And yeah, that's how we use CI/CD pipeline in AWS. Okay, I hope you like the video, and yeah, so see you next time. Thank you for watching and take care. Bye.